We've already cut some strips of lead and polished them with the steel wool so that we can see them if they react. And you see the lead, it's very soft metal. We got that from roof flashing material. And the same way we got copper strips. And we polished that with steel wool to make sure that we could see any kind of reaction. We also set up some test tubes with galvanized steel nails. So the galvanized is the zinc coating on the outside of the nail. We got 3 of those and little pieces of lead to help us get them in and out. Set up, one over here. We have prepared a solution of 0.2 molar copper sulfate, and we're going to add 3 milliliters to that in a moment, to each tube for each section of the experiment. Let me show you now what we expect to happen. It's always good to get an idea of what you expect to happen before you do the experiment. We already checked the activities of the 3 metals we're using, the zinc, the lead, and the copper, and we found that the zinc is more active a metal than either copper or lead. Lead is more active than copper. So in our experiments we should see zinc replacing the lead and being oxidized to zinc nitrate and leaving lead metal in the atomic form. The same way we expect zinc to replace copper sulfate and become zinc sulfate plus 2, and we expect lead to replace the copper sulfate as well. Okay, we have 3 solutions: the copper sulfate, lead nitrate, and zinc chloride, and we're going to add 3 milliliters of each. I'm sorry, I wanted you to see the table. We're also going to keep track of what happens and put in our observations in these rectangles as we go. This will probably help you in your home experiment. Okay, this is the first time we're running through this experiment, and I hope you remember what to do here. It says to add 3 milliliters of copper sulfate to the first set of test tubes. There's one there for the copper sulfate there. We haven't added the lead here yet. To the second tube, put the lead in so we can see it. If it reacts, make sure we have a full 3 milliliters. A little bit short there, we'll add a few more drops later. Whoop, right down the outside of the tube. We haven't done this yet, this is the first run. You can see change already on the lead. I believe we can. And this should be more reactive even the zinc. The copper sulfate is, put some more in there, and a few drops more in here. You see sort of something on the lead. Alright, let's put the lead into our second set. And make sure we have the shiny side out here. The copper. And this will be the lead nitrate. Lead nitrate solution. Should come with your kit actually. That's where we got it. We got it out of a kit. Ooh. About 3 milliliters into each tube. It's hard to squeeze this. And so we don't forget, we can see the copper sulfate because it's blue, but we can't see the lead nitrate. So we're going to put the lead nitrate bottle in front of the 3 samples. And we're going to put lead and copper strips into the other test tubes. Ooh. I don't have any more test tube rack. And we're going to try the zinc chloride solution in those 3. so easy squeezing from these little bottles. We're only getting about 1.5 milliliters for this run. We're going to look at it initially and see if there's been any change right away. I don't see any in the zinc chloride. There's not supposed to be any in there. But I see something on the lead over here. It looks like it's blackened. And the lead here doesn't seem to have reacted. I don't see anything happening with the copper. We're supposed to wait now for 5 to 12 minutes. And just checking the time. 5 to 10 minutes. So we'll check the watch. It's 5 minutes past 1. We'll give it a good 10 minutes. Okay, that's just about 10 minutes, you can see, and we're going to now inspect our materials and make our recordings, our observations, and record it. Here we're going to do the copper sulfate first, which is the copper 2+ solution. We're going to fill those in now. First we're going to look at it. Here's a piece of copper. Nothing has happened to the copper. First glance. Here's the lead. You can see the lead is really brown, it's darkened quite a bit. And here's the galvanized now. And I actually don't see much change in that. We'll compare them with the bright copper. It hasn't been treated at all. And the lead, and you can see the lead has really changed. And the galvanized nail, there's some darkening on the galvanized nail, not much. So we're going to write that in. I'll give you a close-up first, how close we can get without losing focus here, so you can see those. Alright, then we're going to go over to our whiteboard, and we're going to put in our observations. The copper, no change, so we'll put NR. NR, it's hard to write like that, for no reaction. Like that. Ooh, can't write in this position. The lead darkened. Darkened. So the lead has reacted here, and it's been oxidized. And the zinc, slight change. Slightly dark. Boy. Okay? Hard to read that, I imagine. Let's take a look and now at the lead nitrate samples. See what they look like. Let's put these away. Pull out the copper from the lead nitrate. Again, nothing really. We didn't expect that. And again, we shouldn't have had anything here, lead nitrate, because that's lead, it shouldn't have reacted. But the zinc should have, and it's very slight. So we have an oddity. We have an oddity. I'll write our results in. We'll try and figure out why that happened later. For the lead nitrate, we're not supposed to have any reaction. We had no reaction for the copper, that's proper. But the lead actually darkened. We're supposed to have no reaction there. And the zinc, hardly any, very slight darkening, if you can read that. Very slight darkening, okay? We'll take a look at the other zinc nitrate. Zinc chloride, actually. I don't know why that happened. There's supposed to be no reaction here. So we'll put a question mark next to it. Remember that. Wonder why that happened. You always write down your exact observations. I want to look at the other one. Move these away. And a sample galvanized nail. And we'll look at them. Here, on a close-up. Copper. Again, no reaction. We expected that. The lead. This is in the zinc solution. This time, no reaction. And the zinc should have had a no reaction, but you know, where's the pale? This is the untreated nail. Again, very, very slight. Shouldn't have happened there. This is expected, no reaction. Let me turn the camera so you can see the board. Sorry for swinging it that quickly. The next lead was no reaction, that's correct. We expected that also. And the last one was maybe slight reaction. So there you have it. For your table, when you fill it out, the copper sulfate, no reaction with the copper metal. The lead sulfate, the solid lead reacted, darkened anyhow. And the zinc slightly darkened. So we expected that. If you look up here, we expected the lead to react with the copper sulfate, lead to react with the copper sulfate. We expected the zinc to react with the copper sulfate. Both of them were oxidized. Okay? But we did not expect the copper to react with the copper sulfate, and that's what we got. Everything's fine so far. But our second set of observations with the zinc, the lead nitrate, 2.2 molar lead nitrate, which is in the bottle labeled like that. I'm checking now to see maybe something's wrong with the materials. This is right. Copper should not have reacted. But somehow the solid lead darkened. We don't know why. And the zinc again very slightly darkened. So the zinc might have reacted a little bit, and it should have. Okay, it bears out what our theory was. And on the last set of samples, we have no reaction with the copper, which we should have had. No reaction with the lead, finally, which we should have. And maybe a tiny little bit with the zinc, and that shouldn't have happened either. So, you know, this is largely no reaction. So the zincs are probably, okay? I mean, that's figuring backwards, but we have exactly what we expected to happen, except for the lead, which darkened on the lead nitrate solution. Right now, I have no idea why that occurred. But you can report these results. We're actually supposed to have no reaction here. This is supposed to be no reaction. But we had a reaction. And here it is. You can see it right there on the edge, the darkened lead down the bottom.